Hi, I'm T. Kavitha, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajarashmi College of Arts and Science. Today's topic is regression equations in Mathematics and Statistical Computations paper. Regression meaning a study of measuring the relationship between associate variables wherein one variable is depend on another independent variable called as regression. It is developed by Sir Francis Galton in 1877 to measure the relationship of height between parents and their children. Regression analysis is a statistical tool is to study the nature and extent of functional relationship between two or more variables and to estimate or predict the unknown values of the dependent variable from the known values of independent variable. Uses of regression analysis. It provides estimates of values of the dependent variable from values of independent variables. It is used to obtain a measure of the error involved in using the regression line as a basis for estimation. With the help of regression analysis, we can obtain a measure of degree of association or a correlation that exists between the two variables. It is highly valuable tool in economics and business research, since most of the problems of economic analysis are based on cause and effect relationship. Regression lines and regression equation. Regression line of y on x. This line gives an probable value of y dependent variable for any given value of x independent variable. Regression line of y on x is equal to y minus y bar is equal to byx into x minus x bar, or y is equal to a plus b x square. Bx. Regression line of x on y. This line is gives the probable value of x dependent variable for any given value of y independent variable. Regression line of x on y is x minus x bar is equal to bxy y minus y bar, or x equal to a plus by. Regression coefficient. The quantity b in the regression equation is called as the regression coefficient or slope coefficient. Since there are two regression equations, therefore we have two regression coefficients. First one, regression coefficient x on y, symbolically written as bxy. Second, regression coefficient of y on x, symbolically written as byx. Different formulas used to compute regression coefficients. Using correlation coefficient r and standard deviation, bxy is equal to r into sigma x by sigma y. This is regression coefficient of x on y. Regression coefficient of y on x is equal to byx is equal to gamma into sigma y by sigma x. Direct method using sum of x and y, bxy is equal to n into summation of xy minus summation of x into summation of y divided by n into summation x square minus summation summation y square minus summation of y the whole square. Regression coefficient of y on x is byx is equal to n into summation of xy minus summation of x summation of y divided by n summation of x square minus summation of x whole square. When deviations are taken from arithmetic mean, that means x is equal to x minus bar and y is equal to y minus y bar, then we get the regression coefficient of x on y is bxy is equal to summation of xy minus summation of y square. Here x is equal to x minus x bar, and y is equal to y minus y bar. And regression coefficient of y on x is equal to byx is equal to summation of xy divided by summation of x square. Here also x is equal to x minus x bar and y is equal to y minus y bar. Here is the example problem for find two regression lines of x on y. Here x is at 10, 12, 16, 11, 15, 14, 20, 22, and y is 15, 28, 23, 14, 20, 17, 25, 28. We use the direct method. So we add x, find summation of x is 120, summation of y is equal to 160, x square, summation of x square is 1926, summation of y square 3372, summation of xy is 2542. Here n number of elements in either series x or series y is equal to 8. Now we will proceed to compute regression equation using normal equations. Regression equation of x on y, x equal to a plus b y. Therefore normal equations are summation of x is equal to na plus b summation of y, and summation of xy is equal to a sigma y plus b sigma y square. Substituting the values in above normal equations, we get 120 is equal to 8a plus 160b, 2542 is equal to 160a plus 3372b. Let us solve this equation 1 and 2. We get b is equal to 0.8256, and substitute the b value in equation number 1, we get a equal to minus 1.5. Thus we got the values a is equal to minus 1.5 and b is equal to 0.8256. Hence the required regression equation of x on y is equal to x is equal to a plus by, x is equal to minus 1.5 plus 0.8256y. Same like this, regression equation y on x is equal to y equal to a plus bx. The two normal equations are summation of y equal to na plus b sigma x. Summation of xy is equal to a summation of x plus b summation of x square. Substituting the values in above normal equations, we get the below two equations, and solve this, we get a is equal to 3.095 and b is equal to 1.127. Substitute this, y equal to a plus bx. The required regression equation of y on x is equal to y equal to 3.095 plus 1.12x. Thank you.